All right, this is the second section, part 2 of 10.4, polar coordinates, and we left off having looked at using our graphing calculators to sketch this image and to talk about how we determine either from a graphical standpoint or from a trigonometric standpoint what the interval is that we need for it to graph the entire thing one time. And so we're going to go on to another one where it's graphing. You're welcome to use your calculator as well to verify your graph for this, but I'd like to show you how we can also take some of these equations that are a little bit more basic and interpret them and figure out what the graph is as well. So for starters, we've got the equation r equals sine theta, and I'd like for you to take a look here at solving this for sine. For reminding ourselves what sine is in these ordered pair conversions. So we have looked before that sine of theta is equal to y over r, and we're going to be using that. So over here, where I have sine of theta, I'm going to be substituting in what it's equal to. Now, I realize I've still got an r in the equation. Don't worry about that for the moment. We'll catch that. But we'll substitute in sine r, so the sine of r is equal to y over r. So we can actually solve this a little bit, simplify it a little bit, multiply our r to the other side, right? So have r squared equals 2y. Now, while this isn't solved yet for x and y, it's still got the r in it. R squared is another equation that we know something about. R squared is x squared plus y squared. So now that I have an r squared in the equation, I can replace it with x squared plus y squared. And this starts to look like another equation that we've seen and seen very recently. So if I move the 2y to the other side, sorry, it'll be subtraction, and I leave a space, I can complete the square. I complete the square by adding a 1, right? And then I will factor this, so I have x squared plus, and then I have y minus 1 squared equals 1. So what is this an equation of? Well, it's kind of like an ellipse, or more specifically, it's a circle, right? So this is actually a circle with radius 1, right? The radius is 1, and the centers at 0, 1. So we should be able to draw this. So we have a center at 0, 1. So 0, 1 would be right here. Draw it a different color since I've made my hash marks in yellow. So there's my center. My radius is 1. So if we go 1 in each direction, we'll make a small mark here on each of them so I can connect them in a moment. And then we connect these with a curve. It will be a circle. That circle is kind of big. Let me actually make that a little thinner, a little too fat for what we're needing right now. All right, that's not too bad. So this is a circle of radius 1, centered at 0, 1. So that would be a sketch from the perspective of looking at the graph, or looking at the equation and getting the graph instead of using our calculator. All right, not only are we going to convert points and convert these graphs like we just did the last one, sometimes we're going to actually turn them into polar form and then sketch them. So we're going to take this, turn the rectangular equation into polar form and sketch them. So we're going to take this equation, which is y squared minus x squared equals 4. And as you look at this, you might be thinking, like, what is this an equation of? At least I hope you are. It is an equation of hyperbola, so that when we graph this, we need to sort of verify that this works. So this is y squared over 4 minus x squared over 4 equals 1. So when we graph, we'll have to think about how that would look. But we're going to do some substitutions, right? So y squared would be taking the y value, which is r sine of theta, and squaring it. X squared is taking the r cosine of theta and squaring it, and this equals 4. Now you might look at this and say, okay, am I done? And the answer is, well, not quite. I mean, if we're trying to get this solved for something kind of like we solved for y equals, and when we're doing rectangular coordinates, we kind of want it solved for r, or r squared possibly equals for rectangular, or for polar coordinates. So this does become r squared sine squared of theta minus r squared cosine squared of theta. And the r squareds can be factored out. So r squared sine squared theta minus the cosine squared of theta. Now there is a simpler version for sine squared theta minus cosine squared theta. If you haven't already done so, I would strongly encourage you to print out the trig sheet that's inside of Canvas in our informational sheets section. We're going to refer to it both in this particular problem and also in the next section to quite an extent, and you're going to want to use that as a reference point. I don't need you to memorize them right now, but I do need you to really utilize them. So the sine squared minus the cosine squared is actually really close to the double angle of cosine. In fact, it's exactly the opposite. So this is the same as the negative cosine of 2 theta. Okay, so what's next? Well, we're trying to get r, or in this case r squared at the moment, alone. So I have r squared that I'll put the other negative cosine 2 theta to the other side as division. And then if you take a look at, like, what does r equal? Well, r equals positive or negative the square root of 4. We'll put the negative on top. So negative 4 over cosine of 2 theta. All right, so if you were to graph this and you were to work a little bit with your calculator, this doesn't work in all values. In particular, because I'm taking a square root, this square root will only exist when what's underneath it is going to be positive. So if the cosine of 2 theta is positive, this won't work. If the cosine of 2 theta is negative, it will. So I kind of want to know where's the cosine of 2 theta negative. And this actually will work. I'll write it down actually to the side here. Let's come up here. So I want this to be true for when the cosine of 2 theta is negative. And again, that's the reason is because the negative 4 has to be divided by a negative to give me a positive, or I can't take a radical. So if we take a look at when this happens, this actually will happen from pi halves, right? For a cosine graph is negative from pi over 2 to 3 pi over 2. Right, the left-hand side of the graph, unit circle stuff. And if we divide by 2, because it's 2 theta, it'd be pi over 4 to 3 pi over 4. So this is our theta measure that we need to be using. And you can get your graphing calculator to graph this now, right, to sketch this. So you can actually put into your calculator r equals, you can do 2 lines because it says plus or minus, so you need to do r equals the square root of negative 4 over cosine 2 theta. And then underneath it, r equals the negative square root of negative 4 over cosine of 2 theta. As anticipated, it will look like a hyperbola. I'm going to go ahead and draw in our asymptotes. The value negative 4, and I'm sorry, 4 on the right-hand side actually gives us, oops, that was not the right button. Asymptotes that are the lines y equal x and y equal negative x, so it looks like that. And they cross at 2 right here and right here, and then they're drawn out something like this. Okay. All right, one last question. It's a pretty quick one compared to the one we just did. That one was a little bit messy. This one's converting the polar equation into rectangular form and then sketching, so going the other way, polar to rectangular. So polar to rectangular, you might remember that the x is equal to r cosine of theta, which also means that cosine of theta is equal to x over r. So we can take this r equals and we can replace the cosine of theta with x over r. We can multiply r to the other side like we did in the last problem. This is r squared equals 4x. And r squared, just like again before, is x squared plus y squared. And this equals the 4x then. All right, so this feels a lot like the one 2 problems ago. We're going to move the 4x to the other side. We'll leave a space, and there's my y squared. I need to complete the square. That's addition of 4. And factoring here gives me x minus 2 squared plus y squared equals 4. This is actually a circle as well because the coefficients in front of the x squared and the y squared are the same. So this is a circle centered at 2, 0 with radius 2 because of the 4 on the other side. And if we were asked to sketch it, which we are, we will draw over here the ordered pair first. So the ordered pair it gives us is 2, 0. That's where our center is. I'm going to draw some 2's in each direction because I'm going to need them here in a minute anyway. So 2, 0 would be right here. And then we're going to go up 2, left 2, down 2, and right 2 for the other points that we can connect. And our circle looks something like this. We'll shift it a little bit there. And that's it for section 10.4.